Section 8.2, Area and Perimeter of Composite Figures. This lesson refers to or works for both the grade 9 applied and grade 9 academic course. And our goal for today, or what I want you to be able to do by the time you move on to the next section, is be able to find perimeter and area of what I call weird shapes. You see Charlie there in the swing, and maybe I told you this or maybe I haven't, but I will just say that about 2 minutes after that photo was taken, both my children got in a lot of trouble, and you can guess why. Okay, so we're talking about composite figures, and all that means is a shape that's made up of two or more regular shapes. So this, for example, is what I call a composite figure. It's got 3 rectangles. It's made up of 3 rectangles. Okay, so that's what I'll call a composite figure. And if you look down to the next, the example beneath here, it says find the perimeter and area of the figure above. So of this figure here, we want to find the perimeter and the area. You might or may not remember the term perimeter. It just means if you add up all the side lengths, what that equals. And so there's a few things we had to do in this one to make that work. You have to add up all the sides, and almost everything is given to you. 2 things that weren't. One was this distance right here, and I worked that out to be 3 centimeters. And the way that I did that was I said, okay, well, this is 8 from here to here, and we know this is 2 and this is 3. So this distance here must be 8 minus 2 minus 3, the difference, okay? And the other dimension that I wasn't given was the height of this bit right here. We don't need that for perimeter, but we will need it for area, so I thought I'll just discuss it now. And that works out to 4 because this part is 2 and this part is 2. So we have 4 centimeters from top to bottom, or this distance here is 4. So going back to perimeter then, all I'm doing is adding up each side, right? Add everything up, you get 23 centimeters. Assuming I didn't miss anything, I just take every single length that's given. Okay, for every side length here. And just remember that when we say perimeter, that's length that we're talking about it. So centimeters, meters, could be feet, could be kilometers, miles, some length unit, whatever, and you just use whatever's given in the question is the easy way to think of that. You take physics later on, we'll talk about more about going from one unit to another, but not this year. Okay, so then it asks us to find, so that's perimeter, done. Now we're going to find the area of this thing. And so to find the area, and I bet you, half of you got it done already, is you just take the area of each part. So I broke this into three rectangles, right? And because I know the dimensions of each rectangle, and you just add them up, as simple as that. So to find the area of a composite figure, just add the area for each shape. So A1 plus A2 plus A3. And then you have to look at each, and it's rectangles. And so for rectangles, it's just length times width, and I'm sure you remember that. So for area 1, it's 3 times 2. For area 2, it's 3 is the width, and the height is the 4. And for area 3, it's 3 and 2 again. Okay? And so you get a final answer of 24, and the unit is centimeters squared, right? And squared, like I said, it's usually centimeters or meters. If everything's given in centimeters, that's obviously centimeters squared. Okay, so that's just a simple example. If I've gone too fast or you need to, just pause, and then join me on the next example of finding, what's this one? Okay, this is a different shape, but find the perimeter and area of the figure below. I had fun with this one because we had to use pi. Okay, you probably remember from previous math courses that to find the circumference of a circle, which is the perimeter of a circle, it's 2 times pi times r. Okay? And if you look at this shape, and again it's 3 different shapes put together, A1, 2, and 3. If you look at this shape, oh, I made a typo. A1 plus A3 is 1 full circle, right? This plus this equals 1 full circle. So, to find the perimeter of this, like this and this part, you can just treat it as 1 full circle, right? Go 2 pi r. In this case, r is 5 feet, right? Because the whole distance, this whole thing, is the diameter, and that would be 10, so my radius would be half of that, or 5. Yeah, so the circle. So now you can just do the perimeter. It's the circumference plus this distance, 20, and this one will be the same on top, 20. Okay, and then you can work that out for a couple little things is working with pi. Like I say at the very top, I'll put it up here so you can write it down. Pi is approximately 3.14. I would prefer you not put 3.14 in your calculator. There's way more accurate ways to do pi. Your calculator itself has a pi button, should have a pi button. You got a scientific calculator. If you can't find it, look for it now, but if you can't find it, make a little note of that, and tomorrow in class when I come talk to you, we'll find your pi button. Okay, and personally, when I do calculations, I don't do 3.14. Even if I'm doing something where I don't have a pi button, I do 22 divided by 7. But you don't have to do that. But if you put 22 divided by 7 in your calculator, it's almost exactly equal to pi. Okay, it's more accurate than 3.14. But anyways, my point is that you should use the pi button. It's not the worst thing in the world if you do 3.14, but it's not quite right. And no real mathematician would be very happy with you if you did 3.14. Anyway, so coming down to this area, okay, or sorry, the perimeter, doing the perimeter first. 2 pi r plus 20 plus 20. So 2 pi times 5, because r is 5, plus 40, because I just added those two. So 2 times 5, so it's 10 pi plus 40. Okay, so really, when you're doing sort of the simplifying, pi is kind of like an x. It's just a symbol that's sitting there. But what I've done in this last step, and again, you should put this in your calculator yourself, 10 times, hit the pi button, right, plus 40. Put that in your calculator and you should get 102.8. Notice, by the way, how I just added the dot right there. No dot, no dot, no dot. Because as soon as what I had to do was round, right? I rounded to one decimal place, and we'll talk a bit about, I feel like I might have made a typo here too. I'll have to check that out. Yep, this one's wrong, I can tell. I'll fix this one. As soon as you plug in pi and you end up having to round, this dot refers to approximately equal, okay? It's not exactly equal, it's approximately equal. So if we work this out, I better fix this. 10 times pi is 31.4. Plus 40 would be 71.4. My mistake there, sorry. Okay, so 10 times pi in my head is just, I know that. I must have made some typo somewhere along the way when I did the 102.8 or just copied this by accident. But 10 times 3.14 is 31.4, yep, so that rounds to there. So, but notice I got that for approximately equal, okay? Area is just add the 3, and again, since A1 plus A3 is a circle, we can just use pi r squared for that part. And so the total area will be the pi r squared for that full circle, right? Because this will make one full circle with area pi r squared, plus length times width, which is the area of this rectangle. Okay, and so pi times 5 squared plus 20 times 10. L is 20, W is 10, 10, 20, and that equals 102.8 feet. And notice it's feet squared again, okay, for area. Okay, one more example for this note. Another composite figure. This time it's a rectangle and a triangle. And if I want to find the perimeter, I need this length. And you're going to see this so many times in this unit. There's a reason we did Pythagorean theorem first. If I want to find this distance, I need to use Pythagorean theorem to do it. So this is the orange, and that's what you should focus on first. Okay? So I'm going to call this L, just for the sake of argument, and I'm going to use Pythagorean theorem. Right? That says that since this is a right angle triangle, this squared, this distance squared, L squared equals this squared plus this squared. Sort of work through the numbers. There's a square root button, so you get L squared equals 208, and then L is the square root of 208, and again, it's approximately equal to 10.5. As soon as I did this, it was all equal, but as soon as I went from here to here, I had to round, and that's when you add the dot on top, because now it's no longer exactly that number anymore. And if ever you're wondering how many decimal places should I use, you know what, you take my physics course in a later time, we'll talk about what what's appropriate for a given situation if you take up physics in grade 11. But until then, just think of something that works with the question, okay? In this question, there's no decimal places in any here, so at most 1 would be fine. You know, if you used 1 or 2 on any given question, I would be satisfied with that, okay? Don't ever do everything that you read on the calculator. That's just a waste of paper, okay, and a waste of your effort. 1 or 2 decimal places and then is almost always just fine for anything we do, okay? So anyway, so once you've figured out this distance here, now you go perimeter. And then just again, you just add up 12 plus 14 plus 8 plus my 10.5 plus 14 and simply 58.5. Still keeping the approximately equal because this is a rounded number, right? It's not exactly equal to this. This is rounded. Area is the area of the rectangle plus the area of a triangle. And you might remember that the area of a triangle is base times height divided by 2. Okay, so just the dimensions for length and width. Notice I'm doing brackets instead of times. It's not that important, but it is actually a little bit neater, okay? You can put a times in there. Sometimes, especially now, as you know, we use x's all the time. It's nicer to use brackets. It's easier to differentiate between an x and a times, right? So, you know, for communication purposes, I would prefer to see just like this, brackets, no times, okay? And then there's my base height divided by 2. So base is 8, height is 12, divided by 2. Put that in your calculator, work it out, and 216 centimeters squared. Notice, by the way, no approximately equals. That's because I'm just using the numbers given in the question. I never rounded anywhere. None of this is rounded. Okay? All right. Okay, this one, here's my little warning right from the very beginning. Write small. This is a long solution, just to show you before you start writing. It goes all sort of down, 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 down. Okay? Lots to write in this one, and write it small. Okay. So another thing maybe before you do anything else is here, right here, I cross this out, 0.15 per centimeter squared. Okay, so 15 cents per centimeter squared. I made a solid, I don't know if I got this question from somewhere. I wrote this a long time ago, or if I made it up, but it was just a bad choice of numbers. So we're changing it to 0.15 per centimeter squared. Okay, so let's worry just about part A. Determine the area of the frame below. So just sort of this whitish part, not including the picture. Okay, so looking at just part A, the first thing I'm going to say is this is a let statement where I'm going to call AF be the area of just the frame, the white part, or cream colored part. A is this total area, which is the whole thing. Okay, and AP is the area of just the picture. So using the dimensions given to me, you can see in the orange that I figured a few things out. So the height of the picture was, if this whole thing is 72, and this is 16, and this is 6, then the height of the picture is sort of 72 minus 6 minus 16, or 50. Okay, just took these off. And the width of my picture is same idea. Take this piece off, the 11 here and the 11 here, so 82 minus 11 minus 11. So that's for my photo. So when I find my area of the frame then, I take the total area, which is the total length times the total width. Okay, these are all rectangles, so it's all length times width, so 82 times 72, minus the picture, which is obviously 50 by 60. Okay, put that into your calculator. You should end up with 2904 centimeters squared. Okay, now the next question does get quite a bit more complicated, and what I like about this question is it does have a feeling like equeo, right? These are sorts of things that you might see. So it says, what percent of the entire area does the frame take up? So if the frame is 2904, the total area, we never actually worked it out, but it's 82 times 72. What percent is that of that? Okay, so just put this down so you can write it out. So to find the percent, you divide the frame area by the total area and multiply by 100. And I have this thing, and I don't know if it works for everybody, but whenever I'm working out the percent of something, I always think of tests. Like if the test was out of 50 and I got 45, my percent is, the smaller number over the bigger number times 100. Okay, and same with the frame. So you take the area of the frame divided by the total area times 100. Okay, and so for total area, we never worked it out above, so I just put in the numbers, and then I'll assume that you could put that into your calculator, but these are always good practice as I solve the questions, okay? That you put them in the calculator yourself, and make sure you get the same number as me. Okay, now the last part, and again, if I'm going too fast, go ahead and stop me, or stop the tape. Here's the tough one. It says if the material for the frame is 0.15, 15 cents, right, per centimeter squared, determine the cost of the material if you buy an extra 10% and if we include sales tax. So there's a lot going on there. So let's go down to the solution. So thinking we would take the total material for the frame, add 10%, and then add 13% to the price using this cost. So let's see. So to find the cost, you'd follow these steps. Sorry. First, we have to find the total amount of frame material. So you take the A frame area times 1.1. So when you're adding 10% to something, you multiply it by, you could go frame area plus 0.1 times the frame area, right? But that really is the same as taking the frame area times 1.1. Okay, so if you're adding 10%, you just do this. You take the number and times it by 1.1. And then second step, then once you want to find the before tax cost, so now we've got our total amount of material, and you have to multiply that by the cost per centimeter squared. So just multiply it by 0.15. And then to get the after tax cost, using the same idea, once you have this before tax cost, if you want the after tax cost, you take your price and multiply it by 1.13, and that will add 13% tax to it. Okay? So just going through the steps then, and you get the answer. So we have total frame material. Remember, you multiply by 1.1 to add the 10%. Then you get a number. And then you figure out the before tax cost by taking this amount of material multiplied by the cost per centimeter squared. And that gives you your before tax cost. And then to get the after tax cost, you multiply it by 1.13. And there you go, 541. Which is fairly expensive. But I think the way I had it figured out before with the original numbers, it was going to be 50 cents or something. So either way. Okay, long video, long note, but you should be set up for some good questions now.